continuing. This reentry is going to take about 20 minutes or so until our planned splashdown. We were trying to splash down about 1 hour and 6 minutes into the flight.
Yeah, and one day Starship is designed to land on Mars, where there are obviously no runways or other humans to help us out. So we are doing propulsive landing instead of more traditional means such as parachutes. And propulsive landing enables us to have more rapid reusability with these vehicles.
Yeah, the ship itself, it's a little over 50 meters tall. We've got those 6 engines on board, the 3 vacuum, the 3 sea level, and they're down in that aft skirt region, which
flaps have control.
All right, so at this point, the flaps have control. That means we're getting into a dense enough part of the atmosphere that the flaps can start controlling us. We're not only reliant on those kind of reaction control system thrusters.
We're going to continue hearing some callouts as the ship makes its way back to Earth. So when we hear entry max heating and entry max Q, that will mean the ship has made it through the maximum heating and aerodynamic loads it will experience as it returns. So if it makes it through those, we can say we're doing pretty well.
I will say I'm happy re-entry cleaned off this camera for us. It was a little dirty from the weather, so thank you, Plasma, for giving us this view as we start coming down. The hit we saw to the skirt, definitely interesting. I will note, when we started doing these missing tile tests, we were intentionally removing them only in the skirt, as that's, you know, that's not over your fuel tanks or anything else that's kind of structurally critical for keeping the entire vehicle together. That obviously exposes your engines, so that could do some things for our landing burn, but for now, we are obviously continuing with this reentry. We are committed. Indian Ocean, here we come. 50 minutes since launch. We're going to see those colors start to build up a little bit. We are at the point where we're in dense enough atmosphere that the flaps have control. So about 74 kilometers in altitude. And you were starting to see some sunlight, so we intentionally time these launches right now so we have daylight. The sun should actually come up over the horizon on Starship in about 3 minutes. So as we get a little bit further into this reentry, that inky black below you is going to start to look like clouds and hopefully a bright blue ocean as we make our way down onto the other side of the planet. We've got these cameras. These cameras are really cool. We added these several flights ago, looking directly at the flaps as not just the heat shield, but these flaps, how they're able to control the vehicle, withstand that reentry, the seal locations, so kind of where they connect to the ship itself are some of the most critical. We will do missing tiles on those where, again, we're trying to, we're kind of being mean to this Starship a little bit. We're really trying to put it through the paces and kind of poke on what some of its weak points are. I mean, we even have missing tiles over some of those fuel tank sections of the ship itself. And so we're really trying to see what are our limits. We're doing this over a completely empty area over the Earth. Look at our Raptors there. We are, assuming we make it all the way down to the ocean in one piece, we will attempt a flip and a landing burn. We do have at least one buoy, everybody's favorite camera person, out in the Indian Ocean right now, being powered by Starlink. So that's at our planned landing location. So if we're able to get any live views of the ship, that'll essentially tell you that we nailed our target. Able to do that on our 6th flight test, do it in the daytime, which was really exciting. All right, so we're about 10 minutes until we're probably going to start hearing some of the other big milestones coming up.
Yep, in about 10 minutes, like Dan said, Starship will be transonic. This is going to be the period of flight where the velocities of airflow surrounding and flowing past the vehicle are concurrently below, at, and above the speed of sound, so somewhere in the range of Mach 0.8 to 1.2. For reference, commercial jets have a range of cruising speeds, but most of them fly at speeds between Mach 0.74 and Mach 0.85, so that's 480 to 575 miles per hour or 770 to 930 kilometers per hour.
And after transonic comes subsonic. That just means you're slower than the speed of sound. We're still well in excess of that right now. But by the time we hit subsonic, we're essentially belly flopping down. There we go. There's that sunlight. So we're seeing the Earth now come back into view. One of the other things we're doing during this, and you're going to see Starship kind of pitch in some pretty, not extreme ways, but a little extreme, as we're trying to really stress the structure of it, of the ship itself, specifically those aft flaps. So the ones in the very bottom of the vehicle. We're pushing not just how well does the heat shield hold up, but how well does the ship structure hold up. We are pushing it beyond essentially what we think we'll have to fly at to do something like a return to launch site. So again, may not be a very smooth ride downhill, but we're doing that by design. We're really trying to find what are the edges that we can operate at, build up a good data set. But sun is up, clouds and water down below us. We are just about 10 minutes away, a little less than 10 minutes now, until we start hitting transonic and then subsonic. Once we hit subsonic, we're basically just belly flopping. All right, so about 55.5 minutes in, you can see the sun is up. Again, we intentionally designed these flights to lift off in the evening here so we get these daylight views so we can get as good a video as possible on the ship, assuming we make it all the way down. We've got at least one buoy powered by Starlink that's out there in the landing zone in the Indian Ocean, hopefully giving us a view again. If you see any live views, not from the ship itself, that means we nailed our landing target.
Starship is past peak heating.
All right, we just heard the call out that we're past peak heating, so things are looking good so far.
Yeah, looking good. And at this point, again, the flaps are controlling. So this movement you're seeing is that forward flap moving to try and just maintain control, maintain attitude of the vehicle as we're coming down. Checking in on one of our flaps. We got one of these cameras on all four of the flaps, two in the front, two in the back, giving us really good close-up views as we obviously don't have a camera that can see the entire heat shield. These give us kind of the best that we can do. But looking at those flaps is really, those are just, super critical for controlling the ship. You have some ability to maneuver kind of cross range. So as you're coming in, you can see in that indicator at the very bottom right that we've pitched up quite a bit. So again, we are maximally stressing those aft flaps right now. Looks like we got a little bit of burn through the very bottom part of it. Everything's still looking good. Ship maintaining control. We should be just about 5 minutes away until we hear that we're transonic. Still a little bit toasty on the aft skirt of the vehicle as we continue coming in.
Again, we are intentionally stressing the flaps so we can learn all we can.
All right, so now we're already well past peak heating. Just about 48, 49, counting down to 48 kilometers in altitude. Expecting that transonic to come, so transitioning between the speed of sound and subsonic slower than the speed of sound in just a little under 4 minutes from now. And right now we've got kind of a lot of forward momentum, a lot of forward velocity, and then eventually by the time we hit subsonic. All right, here we go. So this is what we've been talking about, where we are going to essentially try to fully deploy those aft flaps and really stress them out. So again, this is meant to test the extremes for the vehicle. All right. See those flaps swinging out? Again, we're putting ship through the ringer on this flight in. It's like we're still maintaining control. All right, flaps earning their paycheck today, getting through kind of that max stressing.
Definitely things looking good so far. We're about 2 minutes out now from Starship becoming transonic.
One cool thing to note as we get some of those views showing kind of the whole length of the ship, one of the changes we made after Flight 6 was to change the tile line a little bit. So we had kind of scaled back the number of tiles significantly, as when we go to catch these ships, you don't want to, I think as Elon said, you don't want to shuck the ship as you catch it and knock all those tiles off. So we knew we were going to have to kind of peel back that layer a little bit. And the first time we did it was on Flight 6, and we saw kind of wrinkling and dimples almost in the ship as we were creating these hot spots in the uneven parts of the heat shield. And so to kind of address that, we smoothed it out. That's why you've got kind of that nice smoothed out black line now on the ship. And just looking at it, we can see kind of a little bit of hot spot, a little bit of warping almost. Near the payload door, you can see a little bit of colored patina up above it, but we don't see those kind of deep, almost, they almost look like gouges on that. So it looks like that's been pretty successful. So, all right, we are less than a minute away from hitting transonic. Again, pretty soon our forward velocity is going to look like it's kind of falling off a cliff, and Starship will look like it's falling off a cliff as we essentially go into our belly flop. If you watched some of the high altitude tests or suborbital campaigns, we were able to test that. It was a pretty fundamental, like, can this thing actually fly? And we were able to prove that out with that suborbital campaign. And that's what we're about to see shortly here. All right, so at this point, we've dropped below the speed of sound, so Starship itself is subsonic. We are starting to chill the engines for a landing burn attempt. Landing flip supposed to start in a little over 2 minutes. Subsonic Indian Ocean, we're on our way.
Starship is subsonic.
There we go. Farewell, space. All right, so coming up in just a little under 2 minutes, so we're going to do the flip and the burn. So we're only using those 3 center Raptor engines, the sea levels, the ones that can kind of gimbal, that can move around and steer. Dipping the nose down a little bit. Got 2 of our engines chilled in, waiting on 1 more. So again, we'll attempt to use 3 burns for that initial flip. We eventually go down to just 2 Raptors for the end of the landing burn.
Just about 1 minute now from that landing flip and landing burn start.
Structurally, we're looking good. Got good pressures in our nose cone for everything. Just about 30 seconds. So again, we're going to look for the flip. So Starship's doing its belly flop right now. We're going to do the flip. Swing out. Let's punch through some clouds first. Here we go.
Starship landing burn startup.
Seeing 3 engines. There's our flip. There's a buoy.
Oh my God.
There's a splashdown.
Oh my God.
Hey. Oh man. Yeah. Farewell, Ship 30.